We are done with Unit 8. That means we got a test. All right. Unit 8 test review. Here we go. Page 1. As always, every page will be a different video, so you can expect 5 videos for this one. Let's get to it. Write the letter of every special quadrilateral that has the given property. All right. You'll have more than one answer for some of these. All right. What does that mean? Well, if I look at number 1, all angles are right angles. All right. So this unit, it's going to be a lot of remembering properties of all of the shapes, right? The algebra here is not too bad. But it's just there's a lot of stuff to remember, and I think that's what makes this unit a little bit difficult sometimes. So all the angles are right angles. Well, that's the definition of a rectangle. All right, so definitely B is going to go here. But notice how a square also has 4 right angles. All right, so there you go, B and D on the first one. All sides are congruent. That is the definition of a rhombus. All right. Also, in a square, all sides are congruent. So C and D are going to go with this one. Um, Diagonals are congruent. That is a property. All right, so it's not a definition, it's a property. That is a property of a rectangle. All right. It turns out, in a square, the diagonals are also congruent. The diagonals bisect each other. That is a property of a parallelogram. All right. Well, since it's a property of a parallelogram, we have to, consider all of the parallelograms here. So like a rectangle is a parallelogram, a rhombus is a parallelogram, a square is a parallelogram. All right. So this property fits for all 4 of those. And then there's a bonus one. All right. Oh, wait, hang on. Wow. All right. 5 minutes in, I already made a mistake. So A, B, C, D, those are going to be the correct answers for number 4. I left one off of number 3. In number 3, the isosceles trapezoid. The diagonals are congruent there. All right. Sorry about that one. Good start. Let's see here. Diagonals are perpendicular. That is a property of a rhombus and a square and a kite. All right, we didn't talk about kites too much. I think we only spent, one section on kites. So I don't think there's a kite question on your test. Right. Exactly one pair of opposite sides is parallel. Well, that is the definition of a trapezoid, right? And also an isosceles trapezoid. Remember, every isosceles trapezoid is also a trapezoid. All right. And the last one here, only one pair of sides is congruent. Only one pair of sides is congruent. Oh, I wrote this. I should know this, right? One pair of sides is congruent. Oh, come on. Isosceles trapezoid. All right. Um, Sorry. Yeah, so if I think about what that shape looks like, all right, something like this. Those two are congruent. The top and the bottom are not congruent. All right, you could have the possibility where, these 3 are congruent, but uh that's the explanation for that one. Only one pair is congruent. All right. Let's see here. Using the given information, tell which quadrilateral QRST is best described as. All right, so what we have here is TR is perpendicular to QS. So where is TR? TR is perpendicular. All right, so these diagonals are perpendicular. So just on that piece of information alone, we know it has to either be a rhombus or a square because those are the only 2 um, in this list here where the diagonals are perpendicular. All right, so now we have to look at this next one, TR, and where's TR? TR is congruent to QS. All right, so these diagonals are also congruent. Well, we know the diagonals are congruent in a rectangle and a square. All right, so this, both of these scenarios only fit a square. All right. Let's see here. We got the next one. I'm gonna do a lot of erasing on this picture. So TP is congruent to PR. Here's TP, here's PR. All right. QP is congruent to PS. All right, so not all 4 are congruent, just, Be careful on that one. We have a semicolon here. It's not, not all four, just the two pairs. And then angle 1 is congruent to angle 2. All right, so what this means is the green one here. This means the diagonals bisect, all right? That is every single parallelogram, all right? But can we get more specific? All right, if we look at point Q, that's kind of the vertex of the overall shape. QS is bisecting that entire angle. Well, which one of these has an angle bisector at its vertex? That is a rhombus, all right? So we're going to go with B on that one. All right, next we have TP. Where is TP? All right, TP equals SP equals PR. And all right, so all four of those are equal. That tells us it is at least a rectangle. Could be a square. Right? Let's see here. And then we have this extra piece. All right, so those go with the red one. And then TQ equals TS. Here's TQ, here's TS. So this one is going to require just a little bit of extra thought. So the red part there, that tells us it's a rectangle for sure. We know in a rectangle, opposites are congruent. All right, so the top and the bottom are equal, and the left and the right are equal. This piece right here tells us the top and the left are equal. So therefore, we can kind of use the transitive property here to say that all four sides are congruent. So this one is going to be a square. And the last one, we got a lot of parallel lines here. So parallel lines, let's see which ones are parallel. We have TQ is parallel to RS, and TS is parallel to QR. All right, and the last one, RT. Where's RT? All right, RT is congruent to QS. All right, so the first part here tells us definitely a parallelogram. All right, and then the next one tells us the diagonals. All right, so these two guys are diagonals are congruent. That's the definition. Well, it's not a definition, it's a property that belongs to a rectangle. All right, so this last one has to be a rectangle. Right, so it says the best. Right, so on like number 11, yeah, it's a parallelogram, but can we go more specific? What type of parallelogram is it? And they're asking for the best kind. All right. And there we have it. All right, on the last one, we got three more for you. Video one's almost done. State whether the information is enough to show the quadrilateral is a parallelogram. All right, circle yes or no. All right, so we have on this first one, AB is congruent to CD. All right, we have AD is congruent, not congruent, I'm sorry, parallel. All right, they're saying, is that enough information to show that this shape here, this four-sided shape, is a parallelogram? And the answer to that is no. All right. So top and bottom are parallel, left and right are congruent. That is not enough. What this shape is, it turns out this is an isosceles trapezoid. All right, it's only got one pair of parallel lines. I do not know that the left and the right sides are parallel. All I know is that they are congruent. So this is not enough information. All right. The next one, we have AC. Let's get rid of this. AC. How about BE? Sorry. BE is congruent to ED, and AE is congruent to CE. Is that enough? Yeah, that's enough. All right. We know the diagonals. I'm going to do a lot of abbreviating here. Diagonals bisect. All right, so that was a property we have of a parallelogram. We know every single parallelogram, those diagonals are going to cut each other in half. All right, so if you want to think about BD, right, that whole section BD there, it's getting cut into two equal pieces, BE and ED, right? So I'm just getting bisected. What letter is that? AC is getting cut into two equal pieces. AE and EC are congruent. All right, so both pairs of, or both diagonals are getting bisected, so that one is a yes. All right. And the last one here, we have angle A. Ooh, that's bad. Angle A. I don't like that. I need to fix that. So this entire angle A and this entire angle C, this entire angle B, and this entire angle D. All right. Is that enough information? Yes, it is. All right. We know in a parallelogram, the opposite angles are congruent. And there you go. That was page one. So that was pretty quick video. Um, I think I hit everything. I don't think I made any mistakes this time. So that's a good spot to end. We will, well, 4 more videos to go. So we'll see you in the next one.